Okay, now what is the impact of power in RL series AC circuit? We discuss power. Or L series AC circuit. Okay, as we know that instantaneous power P is equal to VI, and we know that V is equal to Vm sin omega t. I is equal to Im sin omega t minus phi, because in inductive current is lagging behind the voltage by angle phi or 90 degree. Okay, so P is equal to Vm sin omega t multiplied by Im sin omega t minus phi. I already explained this formula in inductive AC circuit, so if someone having any confusion regarding this formula, he may take help from that video. Okay, so we can also write it as 1 over 2 Vm Im cos phi minus 1 over 2 Vm Im cos 2 omega t minus phi. Okay, so this is the constant part of that instantaneous power, and this is the variable part of that instantaneous power. So number 1, average value of 1 over 2 Vm Im cos phi is same, but the average value of 1 over 2 Vm Im cos 2 omega t minus phi over complete cycle is equal to 0. So P is equal to, we can write it as 1 over 2 Vm Im cos phi minus 0. P is equal to Vm Im divided by 2 cos phi, and we can write it as Vm Im over square root 2. This means that Vm divided by square root 2 multiplied by Im divided by square root 2, and that cos phi. Here this cos phi is known as power factor. I also make a series of videos on this topic, so if anyone having confusion regarding power factor, I may take help from this series of the videos. Okay, so P is equal to, here this is the V RMS multiplied by I RMS cos phi. Okay, or P is equal to V I cos phi, where this value is the RMS value of the voltage and this is the RMS value of the current, and this is the power factor. So cos phi is equal to resistance over impedance. I explain it in power factor video. Okay, so you may take help from that particular video. So, and V is equal to I Z. I is there, and cos phi is equal to R over Z. So Z cancel out each other. So P is equal to I multiplied by I square into R. Okay. Now in series AC circuit, RL series AC circuit, power is only consumed in resistive part of the circuit, and none of the power is consumed in inductive part of the circuit. Okay, so power is only consumed in resistive only, because inductance does not consume any amount of power. Okay ji. Now we draw the curves for voltage or waveforms. Waveforms for current, voltage and power. So this is the waveform for current, voltage and power. As we know that in inductive AC circuit, voltage is leading the current by 90 degree by phase angle phi. So we draw it here. Okay. So this is the 30, 90, 90 degree and 180 degree. Okay, because at 90 we get the peak value, and this is the power. Okay, and this is the magnitude of voltage and current. We can say this as the average value of power, or average power is equal to Vi cos phi, and this is the omega t, angular frequency multiplied by t in time. So in inductive AC circuit, the average power is equal to 0 here, and in resistive AC circuit, or the behavior of resistor in series AC circuit, power is only consumed in it. So thus, to make the graph more illustrative, it is explained earlier that current lags behind the voltage by 90 degree. Okay, this is the current and lagging behind the voltage with the phase angle phi and equal to 90 degree by voltage by 90 degree, and here in this case this is the 30 degree. Okay, because at 30 degree it lags, so phi phase angle is equal to 30 degree. Thus it is clear that power is negative. Okay, minus sign I show it here means is negative between 0 degree to 30 degree and between 180 degree to 210 degree. This is the 210 degree. Okay, so this is the negative power. This is the negative power. This is the negative power. What I mean negative power I discuss is after that. So now during the rest of the cycle the power is positive, means rest of the cycle from 30 to 180 degree this is the positive power, and from 210 to 360 degree this is the positive power. Means positive power it gives to the circuit. Okay, and negative inductor gives power to the RL series AC circuit, and negative power means circuit circuit gives power to the inductor, means it's positive power, and means negative power means that inductor sends back some amount of power to the circuit. Okay, this means that power is being consumed by the what does it mean that during now during the area under the positive loop is greater than that under the negative loop, so the net power is positive over the cycle. Okay, this means that the power is being consumed by the circuit in RL series AC circuit. Okay, however it is less than the average power consumed by a comparable circuit where voltage and current are in phase. Voltage and current are in phase. Okay ji, means pure resistive circuit. So the negative area, that negative area, okay, the negative area indicates that inductance of the circuit returns some amount of power to the source during that interval. Okay, means for positive power means circuit given power to the inductor, and for negative power means that inductor sends back some amount of power to the source as well. Okay, so in order to summarize our today's lecture, we can summarize it here in our today's lecture, or we can conclusion that in RL series AC circuit, number 1, voltage leads the resistive voltage by 90 degree, and current I is in phase with VR and lags behind VL by 90 degree and lags behind V. Okay जी, voltage V lags behind VL and leads V of R. Okay, in RL series AC circuit, impedance Z is greater than resistance R, and impedance is greater than inductive reactance XL, but summation of R plus XL is greater than Z. Similarly, voltage is greater than resistive voltage and voltage is greater than inductive voltage, but summation of voltage drop across resistor R and voltage drop across inductor L is greater than the supply voltage V. Okay जी. Also, last but not the least, increasing frequency F causes inductive reactance XL to increase, because XL is equal to 2 pi FL. So increasing frequency will also increase inductive reactance XL, and thus the phase angle phi also increases. Now where RL series AC circuit is usage at low frequency, RL series AC circuit is used as low pass filter, and circuit behaves as resistive circuit. Okay, and at high frequencies okay G, at low frequency RL series AC circuit is used as low pass filter, and circuit behaves as resistive circuit. And at high frequencies at high frequency RL series AC circuit is used as high pass filter, and the circuit behaves as inductive AC circuit. So, end of lecture. So I hope you enjoyed today's video. If you have any confusion regarding today's lecture, you can share your thoughts in comment section. Have you any questions, then you can also ask your questions in the comment section. And if you enjoyed today's video, then like, share and subscribe Electra with MZ YouTube channel. In the next video we discuss impedance triangle, so stay tuned. Till then, stay safe, stay at home. Allah Hafiz.